Section 4.3, Interactive Assignment, Objective 3. A professor feels that there is a relation between the number of hours a statistics student studies each week and the student's age. She conducts a survey in which 26 statistics students are asked their age and the number of hours they study statistics each week. She obtains the accompanying results. We're going to complete parts A through E. So the first thing we're going to do is we're going to go ahead and then open this up into StatCrunch. So I'm going to open up the data in StatCrunch. Okay, and so the first thing we want to do is we want to draw a scatter diagram and see which one it best fits. So we're going to go to Graph, we're going to select Scatter Plot. We're going to make sure our X variable is the age of X here, and the Y variable is the hours studying. And then we're going to go all the way down there and make sure our points are labeled here. And we're going to go ahead and then make sure that we label both the X. So remember, the X is the age and the Y-axis is the study time. So here we go ahead and graph. All right, so if we take a look at this graph over here, okay, this doesn't match A because you can see that this point all the way up here is not located in that graph. Now, if we take a look at B, we can see that all this is contained over here with this point over here, so that might be a solution. Okay, if we look at this one has all the points jumbled up over here, but none of them are out here. And then if we look at the D, we have all these points, and then there's this one. So let's just match to make sure that we are correct here. So if we take a look at this graph, and then compare it to this graph, okay, we will see that this is very comparable to this one here. So we know that our answer for this one is going to be B. Okay, next what we want to do is we want to determine if there's any potential influential observations. Okay, so if we take a look at this graph, we can see that this point over here, if we highlight over it, it's going to give us the value of X, which is age, and the value of the study time, which is 8.3. So that means that X was 36 and Y is 8.3. So that would be a possible potential influential observation. So if we take a look at our information here, we would select 36, 8.3 as a potential influential observation. Okay, now what we want to do is we want to find the least squares regression line using all the data points in our table here. So in order to do the regression line, we're going to go ahead and select Stat, and then we're going to go all the way down to Regression, and then we're going to select Simple Linear. Okay, we're going to make sure our X variable is X, we have our Y variable is there, and then we're going to go all the way down, make sure everything is selected here, fitted line plot, and then we're going to select Compute. Okay, so let's take a look at this information. All right, so if you look here, here is the intercept, and then here is the slope. Okay, so you can see down here where it says parameter, intercept, and slope, and there is the estimate. So let's take a look at our result. We want to make sure that we round the slope to 3 decimal places as needed. So if we round the slope to 3 decimal places, we end up getting 0.234, which is what we get over here. And then the y-intercept, we want to round it to 2 decimal places because that's what it says here. So going to 2 decimal places means that this 6 is going to round this 6 up over here, which gives us negative 0.97. Okay, so there is our information there. All right, now what we're going to do is close out of that, and then the next step, what they want us to do is they want us to find the least squares regression line when we remove the data point of 36, 8.3. So what I'm going to do is I'm going to go ahead and I'm going to copy all of this in the table. So I'm going to copy that over here. Okay, and I copied everything, but I did not include the 36 or the 8.3. So I'm going to write up here, I'm going to put in age and then X with 36 removed. Okay, and then here I'm going to write hours studying, which is Y, with 8.3 removed. Okay? And so now I'm going to use these two columns. So now I'm going to go to Stat, and now I'm going to go to Regression, and then select Simple Linear. We know that the age is with the 36 removed, and the hour studying is with 8.3 removed. Okay, and then we want to go ahead and then select Compute. Okay, now let's take a look at this line here. So we're going to say, okay, well, here's the intercept, here's the slope. Now the slope needs to be rounded to 3 decimal places, and we can see that we get 0.157. So let's check here. We get 0.157 for our slope. And then our y-intercept has to be rounded to 2 decimal places. So the intercept here, we round it to 2 decimal places, so that's 0.59, and we get 0.59. Okay? All right, now, in the next step, what they want us to do is they want us to now be able to draw each least squares regression line on a scatter diagram obtained in Part A. So, the StatCrunch doesn't give us that option, which is the reason why we have 2 of them. So if you go back to StatCrunch over here, and then these are the ones that are hidden. So we're going to open up number 2. Okay, and then we're also going to open up number 3. Okay, so what this does is, I'm going to kind of maximize this just a little bit so you can see the graphs. Okay, so what we're going to do is we're going to go to the right here. We can see what this line is, and this is with the point included. So the point is up here and it is included. And then if we look at this point down here, this is the point where that data is not included. Okay, this is with those values removed. So we have to decide which one does this represent. Well, if we take a look at this first graph, okay, let's take a look at the first graph and let's compare to our graphs here. Okay, now if we look at this graph here, okay, the fitted line here is this one, and that's the one that would be in blue because this is the one that includes this point. Well, if you notice that this line is above that influential point, so we have to not include the first part A. Let's take a look at the next graph, B. Okay, so taking a look at the graph B, again, we can see that this line here is above that influential point, and this line here is below. Okay, even though we have this point here. Okay, next, we're going to take a look at this graph here. Now, this one could be close. So we can see here that this line is below, right? Below that influential point, but this line is a lot lower than this line here. So the blue and the red should not be as close to each other according to what we do when we compare these two lines. Okay, and then let's take a look at this last one here. Now, when we take a look at this last one, and let's compare it to the graphs that we have, you can see that here we have this graph, which would be the blue, and then this one is right below. So this matches it perfectly with those two graphs if they were graphed on a same axis. Unfortunately, we have to look at both of them to be able to compare those two. So therefore, the answer is D. Okay, now the last question says, use the regression equations in parts B and C to comment on the influence that the point 36 and 8.3 has on the regression line. Well, let's take a look here, okay? Now, here's the slope. The slope was before we removed it, was 0.234. And when we removed that point, it decreased. The slope decreased to 0.57. And if you notice that our y-intercept was originally at negative 0.97, and that it increased to positive 0.59. So we're going to answer the question. We're going to say that the point 36, 8.3 substantially affects both the slope and the y-intercept of the least squares regression line.